So I've been looking at a lot of videos in order to show some people what the difference is between raster and vector images. And every example, every article I've read, every YouTube video I've watched, they get a little too technical and they lose the beginning viewer. And I thought I'd take a little stab at it myself, maybe strip away some of the complexities and just take it down to its very basics as far as I know it. So that window you first saw on the screen was just me right-clicking my desktop on a Windows PC and going to Display Settings, and I'm on Windows 10. And I go to Advanced Display Settings, and here you can see all four of the monitors I have plugged into my PC. We're staring at monitor number 2 right now. I do have a monitor to my left and one to my right, and one under the one we're staring at. Now, if I highlight monitor 2, you could see my resolution for this monitor is 1920 by 1200. So 1920 by 1200, what does that mean? Let's take a look. If you've ever got close enough to an old CRT TV before we had LCDs, you would see in this top left picture what the pixels look like. What the image was made up of was a red, a green, and a blue, known as RGB. And that would make up the pixels that would form the image. It would just light up the color that it needed to form the image on each individual pixel. So that was considered one pixel when you got all three of those colors. This one's an old PC CRT, which is the monitors we had before we had LCDs, the big old clunky things that look like a TV attached to your PC. And that's what the pixels look like on PC CRT. This is a modern day LCD on the bottom too, and what their arrangements look like if you were to get close enough. So 1920 by 1200. So let's go back here. So basically, from my top left of my monitor to the top right, I have a row of pixels that equal 1920 across. And I've got a row of pixels that are 1200 from the top to the bottom. So that's just one row. We open a calculator and we times it, 1920 times 1200, we've got 2,304,000 pixels. So if you're just calculating one row, it's 1920, and then down the side 1200. Well, all those pixels in between, from the top left to the bottom right, are multiple rows equaling over 2 million. Some of you may have noticed that you had a stuck pixel on your screen. It happens to some monitors. This is what it would look like. One individual pixel will stay stuck on a certain color. It's called a stuck pixel. There's also a dead pixel, which is a pixel that won't light up at all. It's just black. Well, by now you're probably wondering, what does this have to do with anything? To show you what a raster image is, we need to know the pixels of an image. And I downloaded this PNG file off of Google image search. And we're looking at 100%. You can see right here 100% zoom ratio, which means this is the exact size that it is. That's zooming in, and here's zooming out, 66%. We're going to put it back to 100, and we're going to look at the image size. And I'm in Photoshop, and I'm going to click image and come down to image size. And right here under dimensions, you could see that this image is made up of 532 pixels by 290 pixels. And again, that's just one row across and one row down. So this has 532 times 290 equaling 154,000 some odd pixels. Quite small in the scheme of things compared to the entire resolution of this screen, which was over 2 million pixels. So if you find out this image is not big enough for your project, it's only filling a small portion of your t-shirt size, you're going to try to upsample it. You're going to try to make it bigger. You're going to come to image size and you're going to be like, I need, switch it to pixels, I need it to be 1,000 pixels. Now you can see I'm still at 100% and it's almost doubled in size, and you can see now it's a lot blurrier. Well, what's going on here? I'm going to Control Z to undo that. What's going on is the bigger you make something, the blurrier it gets. And Photoshop nowadays has a feature where you can see the individual pixels. If I zoom in, I can go all the way to an individual pixel, and you can see that pixels are just a bunch of colors that make up detail. The more colors and the more pixels you have, the more detailed you get. Let's get it back to 100%. But if you downsample, if you make something smaller, the pixels get more condensed and you get more detail. So the smaller something gets, if you have something at 100% and you make it smaller, the more detailed it's going to look. So now if we use our roster image on a Merch by Amazon shirt, let's see how that works out. And I'm going to open a new document by going to the File menu up here and choosing New. And I already have a preset made for Merch by Amazon, which gives me the 5400 by 4500 by 5400 300 dpi requirements for Merch by Amazon. I'm going to click OK, and there's the merch template. And I want to use my pizza, and I'm just going to use the move tool right here, and I'm going to drag it and touch the new document that I opened, and then I'm still holding the left click and I'm going to drop it in there. As you can see, it's mighty small compared to the dimensions of the Merch by Amazon template, so you'd be tempted to Control T for transform and stretch it out, but in doing so you're going to lose quality, and that doesn't look bad. But you also got to remember, look right here, we're looking at 16% zoom rate, so at 100% zoom, yeah, it looks pretty bad. Now it may or may not look bad on a t-shirt, but you typically want to look for higher pixel images, and that could be done easily just by, let's open a Google window here and type pizza, go to images, and here's the image that I downloaded. See, it's, if you just even highlight it, it'll show you the pixels, 532 by 290. So let's click that, and if I wanted a bigger one, right here I can go to the page that has that image, or I can just view the image at the pixel size that it is. Or if I want to look for a bigger one, I would come right here. Here's the pixel size. I would come right here behind the pixel size where it says search by image, click that, and more often than not you can find bigger sizes by looking right here, all sizes, and I'll show you every resolution that somebody on the web is using it at, and it looks like 532 by 290 is the biggest one that there is. But that's just one way you could typically find a bigger version of it. Let's see another example, like maybe this one. If we search by image, no other sizes of this image was found. Trying to give you an example of finding a larger one. So this one's 600 by 324. Let's go to all sizes, and you can see here's one for 12,000 pixels by 648. So that's a way bigger version that you could use in your document. But that is how a roster image works and how resolution works. So Photoshop is a roster-based software. Let's take a look at a vector-based software, which is Adobe Illustrator. And I've downloaded some vector artwork, and vector artwork comes in a few different formats: EPS, AI for Adobe Illustrator, or PDF. And this file that I downloaded comes with an AI and an EPS. Both of them will do the same thing. I'm just going to drag and drop them in here. Get that off the screen. And if they come in one of those three formats, a PNG is a raster file. If it comes in an AI or an EPS, and in some cases the PDFs can hold either one, a raster or a vector. Typical vector formats are AI and EPS. If they come in AI or EPS format, they're completely editable pieces of art in vector format. And what is a vector? A vector is a mathematical path which makes up shapes. So say a circle. It's a mathematical path. Let me take the color out of this. You see this outline right here. The circle is just a path. You can make your own path, or you can use these predefined shapes, which are just a series of paths. And since it's a mathematical equation, add some color to it. If I zoom in on it, it doesn't pixelate like a raster image. It never loses quality. It's just a perfect mathematical line, which means that the system keeps track of the math equation, and you can zoom it up without losing quality. You can zoom it up 100 times its original size if you need to, as long as it's in vector format. So these owls that I downloaded are all made up of individual shapes, and I'll show you that right here. Let's just get a corner one. If I highlight this, you can see all these paths light up. That means everything's grouped together. I can right click it and say ungroup, and you might have to do that a couple times, but it looks like I only had to do it once. So now I only have this owl selected, and he's all grouped together. So I can ungroup the pieces, and now you can see that this owl is made up of nothing but mathematical shapes. Even the nose is two different shapes with two different colors. You can pull those apart. There's a bunch of triangles, and if I just keep on grouping, I could see what this owl is made of. A bunch of triangles all grouped together. So typically vector artwork has a certain look to it because it doesn't get too detailed. It's real clean shapes. And here I did a Google search for vector art. You can kind of get an idea of what vector art looks like. Instead of a photograph, you got this real graphic illustration look to it. And I've seen some really detailed, realistic looking stuff done in vector, but there's very few people do it. It takes a lot of know-how and a lot of hours to manipulate the blend modes and all the shapes to make it look realistic. So most people tend to have a look like this, which is what a lot of people are going for anyway. So going back to Illustrator, if I want to use one of these owls in my t-shirt, I can just highlight the whole thing. It's already grouped together, so I can just move it as one piece, and I'm going to copy that and open a merge template. I'm going to paste it here, and as you can see, like the pizza example, it comes in at the size it was on this document. The merge document happens to be, like, I don't know, 50 to 100 times the amount of pixels that whoever created this document had created this document in lower amounts of pixels. So when I copy it in, it's literally this size. But since it's vector and it's mathematical paths, I can scale it up as much as I need to without losing quality. At which point I will need to save it to a PNG format in order to get it uploaded to the Merch by Amazon site. At that point, I'm essentially pixelating it because PNG is a raster format. And I have a little chart here that's like a little cheat sheet. So the vector column here has file formats in AI, EPS, PDF, and SVG. So if you opened up a Google browser and said owl vector, and say you downloaded one of these and it wasn't in one of those formats. Let's see. Well, say you get a PNG file. See how PNG's on the raster side? It's not going to be an editable vector. So when you pull a PNG into Illustrator, it won't be editable unless it's in one of these formats. See, a PNG is raster, so you wouldn't be able to edit the owl. It would just be pixelated, but you can bring a raster image into Illustrator and work with it. You just can't work with it as a vector. So that's raster and vector, the best I can explain it. When you go to print something, you're going to be dealing with DPI, which is dots per inch, and that is a whole nother video. But for now, I hope that helps.